For these last two problems, we had horizontal asymptotes that worked out to be nice single numbers, 0 for A and 3 for B. But the question becomes, what if it doesn't work out so nicely? And that would be what we're going to see in 3C. So we have h of x, which is 1 minus x cubed over 2x plus 8. And my recommendation to you is to use the same trick that we used. As a matter of fact, it's a trick that will consistently work for these problems, which is that we're going to multiply by the highest power in the denominator. So we're going to multiply by 1 over x divided by 1 over x. So you divide by highest power. It's what we did for both of the other ones too, and it just works out beautifully. Okay, so if we do that, then we will be taking the limit of a slightly different function. So let me start with the right-hand side. So on the right end, we were taking the limit as x goes to infinity. Now think about this. You're going to multiply both of these terms by 1 over x. So that'll be 1 times 1 over x, which is 1 over x, minus x cubed over x, which is x squared. And I know you're worried about the fact that it didn't cancel. That's okay. That's kind of what I was expecting. And then the denominator would be 2x over x. So that would be 2 plus 8 divided by x. All right, so now is when that other theorem is going to come in handy for us, because we know that 1 over x is going to be 1 over infinity, which is going to be 0. And 8 over x is going to be 8 over infinity, so that's going to be 0. But what's intriguing is this part up here. So we're going to have, let's see, 0 for this term, 0 for that term, but not 0 for that term. So it's going to be 0, take away infinity squared over 2 plus 0. Okay, well, I have negative infinity squared, and then I divide it by 2, which means I have negative infinity. No horizontal asymptote on that side, not on the right side. So there's no horizontal asymptote on the right. All right, now let's do the left-hand edge. So the left-hand edge, or end, I should say, would be the same thing, but it's the limit as x goes to negative infinity. But the simplification part still works. It's still 1 over x, it's still x squared, it's still 2, and it's still 8 over x. Like, that part doesn't change. But 0 over negative infinity is still 0. Actually, not, I apologize. 1 over negative infinity is still 0. And then this is now minus negative infinity squared. And then this is 2 plus, and then this part is still 0. So that's still 0 there. All right, that means that I have, again, negative infinity squared, because negative infinity squared here makes positive infinity, and then a negative out in front makes negative. So there's 3 negatives there, so it's going to be negative infinity squared over 2, which is negative infinity. So there's no horizontal asymptote on the left either. All right, so there's no horizontal asymptotes, period. Now, there could be a vertical asymptote for sure, and there's not going to be a slant asymptote, and I'll remind you of why that is in just a second. But let's do the vertical asymptote first. So the vertical asymptote would be when the denominator is equal to 0. So that would happen when 2x plus 8 is equal to 0, which is rather obviously, well, here 2x equals 8, x equals 4. So we're going to have a vertical asymptote for sure. So the vertical asymptote is at x equals 4. But there's no slant asymptote, no oblique asymptote. And that's because when you have an oblique asymptote, it has to be that the degree of the numerator is only 1 higher than the degree of the denominator. This is degree 3, this is degree 1. So that's not going to work. It would have to be like squared and x, or x cubed up here and 2x squared down here. That would have a slant asymptote. But there's no slant asymptote here. So let me just make a little note. None, because the degree of the numerator, I'm just going to abbreviate that, is not 1 higher than degree of denominator. It has to be that way. So since it's not that way, we're not going to bother. All right then. So we have a vertical asymptote. We have no horizontal asymptotes on either the left or the right. And then we have no slant asymptotes. So should be a rather easy function. However, if you'll notice, I actually gave a window on this one because right here, graphing window, because the scale on this one's a little weird. If you just look at it up close, you'll think it's, well, a vertical line, but it completely is not. So let me grab that graph for you. Whoops, and looking at this, I realized as I look at this that I messed up the algebra just a tiny bit. It should have been -4 for my asymptote. And I actually didn't even abide by my own scale. I went from -40 to 40 roughly, and -400 to 400 roughly. But you can see that x goes to -infinity over here, x goes to -infinity over here. So we were indeed correct about both of those. And then x equals -4, sorry about that, is my vertical asymptote. So if I go back to the graph, there you have it. So I just drew it in there. That was meant to be straight, but I'm drawing by hand, so what you going to do? So this should be a straight vertical line going straight down. And I've labeled that vertical asymptote, and then there weren't any other asymptotes. You can see over here, the right end behavior is going to -infinity, right at the right end. And then over here, the left-hand end is going to -infinity as well, just like we said it would. So we were indeed correct when we said up here that we had no horizontal asymptotes on the right and the left. We were plummeting towards -infinity on both sides. And also we have no slant asymptote. There just isn't one in this particular graph. And -4, was my vertical asymptote. X equals -4.